In this video, we're going to be understanding the key concepts of OOPS. Object-oriented programming, otherwise known as OOPS, is a model of programming based on the concepts of objects, which can contain data and code to manipulate that data. An object is a self-contained package of data and instructions that works together to represent a real-world concept or thing. So why use object-oriented programming? There's 4 main features. Modularity, which means that the code is organized into discrete objects, making it easier to manage and understand. Reusability, where classes can be reused across different programs or parts of a program. Scalability, which makes it easier to manage growing code bases. And maintainability, where changes in codes are easier to implement with minimal impact on other parts of the program. Now let's look at the key concepts in OOPS. There are 2, which are objects and class. Objects are like the building blocks of OOPS. They combine data with instructions that operate on that data. A class is a blueprint that defines the variables and methods that an object of that type will have. Let's look at this example here. The code defines a dog class with attributes breed and age, then creates an object dog1 from this class. Then it sets its attributes to golden retriever and age 5, as you can see here. Then we print out the details of the dog using formatted string literal. Now let's look at the init function. The init method, often referred to as the initializer or constructor, is a special method in Python. It's automatically called when a new instance of the class is created. The purpose of init is to initialize the object's attributes with the values passed to it. Now let's look at this example here where we've defined the init function. There's 3 components, namely self, self.name, and self.age. Self is a reference to the current instance of the class. It's used to access variables and methods associated with the object. The line self.name is equal to name assigns the value of the name parameter to the name attribute of the current instance, which is self. Similarly, self.age is equal to age assigns the value of the age parameter to the age attribute of the current instance. Next, we look at inheritance. Inheritance in Python allows you to create new classes that inherit properties and behaviors from existing classes. It's a powerful tool for code reusability and for building complex relationships between the objects. The new class inherits attributes and methods from the existing class. Let's look at this example. Here, animal class has an init method which is used to initialize the species and age attributes, as we can see here. The make sound method is defined but not implemented in the base class. The display info method prints the species and age of the animal. Now let's look at how to create a subclass. In this dog subclass, dog class inherits from animal class using this syntax class dog and in brackets animal. Then the init method of dog calls the init method of animal using the super and then bracket syntax. It adds an additional attribute breed. Next, the make sound method overrides the make sound method of animal to specify that a dog barks. Display info method overrides the display info method of animal to include information specific to dogs. Note that in Python, the super bracket is a built-in function that allows you to call methods and access attributes in a superclass from a subclass. It provides a way to delegate method class to parent classes without explicitly naming them, which helps in achieving method overriding and accessing inherited methods and attributes. Now let's combine inheritance and classes to create inherited classes. Look at the syntax on the left and try to guess what it means. Now compare what you thought with the explanation on the right. Instances of both animal and dog classes demonstrate how inheritance allows code reuse and specialization, enabling different types of objects with shared and distinct properties and behaviors. Next, we look at encapsulation. Encapsulation is one of the fundamental concepts in OOPS that bundles data and methods that operate on the data into a single unit called a class. It helps in hiding the internal state and implementation details of an object from the outside world, allowing controlled access to certain parts of the code. Let's look at this example. Here, the bank account class defines a bank account class with attributes account number and balance. For initialization, the init method initializes the account number and balance. Then we use something called the getter and setter methods, where the get balance is a getter method that returns the value of the private attribute balance, and the set balance is a method that sets the value of balance after validating it to ensure it's not negative. Next, account number is accessed directly to demonstrate protected access, though it's not strictly enforced in Python. Encapsulation in this example demonstrates how to protect data within a class and provide controlled access to it, enhancing code reliability and maintainability. Next, we move on to polymorphism, which is a core concept in OOPS that allows objects of different classes to be treated as objects of a common superclass. It enables objects to be processed in a generic manner while leveraging their specific implementation of methods. Let's look at this example of creating a superclass. Here we have a superclass animal with a method makeSound that prints a generic sound for any animal. Then we create subclasses dog and cat that inherit from animal and override the makeSound method with their specific sounds. Here we are demonstrating polymorphism by creating objects of dog and cat classes, treating them as objects of animal class and calling their overridden methods. Animal class defines a superclass animal with a method makeSound that prints a generic sound. The subclasses dog and cat inherit from animal and override the makeSound method with their specific implementations. Next, the polymorphic function makeAnimalSound is a function that takes an animal object as an argument and calls its makeSound method. Despite being either a cat or dog, the correct makeSound method is called based on the actual object type or polymorphism.